Hey friends, here, this is Jim with Science Talk, and kind of a follow-up report on the video I just talked about. What's happening with the warming oceans. In that previous video, I discussed how fish and other organisms, invertebrates as well, are moving north because the water is getting too warm for them, so they want to go to where it's cooler. Well, they're moving to areas where people cannot readily access to harvest them. And also, when they're moving north, they're not only just moving north, but they're also moving more to open water, because coastal waters will tend to warm up faster than the ocean, open ocean does. So it's getting a little harder to reach the fish to fish them. So that might be good in terms of the fishery population being able to recover, but what is impacting here is that there's less harvesting, so the food supply is decreasing. Now, we can talk about, the human population ever increasing, putting stress on that, and that's not sustainable. We can talk about that, and that's certainly something that needs to be considered. But in general, right now, we're talking about warming seas is affecting fish, affecting the distribution, affecting the survival, it's affecting the food supply, which means less food for human consumption. So this is a study that appears in the journal Science. Okay. One of the authors on this research is Malin Pinsky of Rutgers University. And there's several other folks involved here, and I'll be mentioning them as I continue to discuss this. In the last 80 years, there has been an estimated drop of more than 4% in sustainable catches for many kinds of fish and shellfish. That is the average. In some regions, the East China Sea, for instance, and Europe's North Sea, the estimated decline was between 15 and 35%. Yeah. Last year was only the fourth warmest for air surface temperatures, but the warmest since records began for the world's ocean. Remember the lag effect, right? But the specific heat of water. So U.S. researchers report in this journal Science, as I just mentioned, that they looked at the impact of ocean warming in 235 populations of 124 species of fish, crustaceans, and mollusks in 38 ecological regions between the years 1930 and 2010. That's your 80 years. So it's a very comprehensive study. They then matched the world data on fish catches with ocean temperature maps to estimate what warming has done to the sustainable catch, that is, the biggest haul fishing crews can make without reducing breeding stocks for the seasons to follow. This is where fisheries management comes into play. You do all sorts of data collection, you run all sorts of population statistical analyses. It's very complicated. I'd rather stick to calculus, thank you very much, and vector calculus and gradients and curl. That's much easier in my mind. But I can do it, I just don't like it. But these population biologists then say, okay, looking at year class strengths, etc., they then make a determination as to what is an allowable amount to be harvested so that there's sufficient number of breeding, parents can be allowed to breed, and using what's called the recruitment, say, okay, if we allow so many, say, breeding females to survive with the average fecundity is the number of eggs they on average produce, and then we take into account the recruitment. In other words, let's say you have all the eggs that are laid and all that hatch, what have you, of all those eggs, 5% survive so that they can grow up and breed. Then you base that and say, okay, we need this number of breeding females to be allowed to pass through. Don't allow enough breeding females, you're not going to have the appropriate recruitment, so that years down the line, the year class strength is kept up and you can have returning breeding adults. That was an extremely truncated version of what population dynamicists do. You look at year class strength, which is based on the survivability, or what's the mortality rate for the 0-year class. No, those are just hatching. You look at the fecundity, which is how many eggs a female will produce, and say, okay, if a female produces 20,000 eggs, 5% survive. Okay, right? You can do the math there. That's what, 400 or so. So then you base it on that. 400 times the number of females that we're estimating are existing in the population, and there you have it. We make a decision. As you can suspect, there's a lot of error involved with these statistical analyses. But it is what it is. These guys do the best they can, and they do very good work. In fact, the Alaska Department of Fish and Game, especially the Fishery Division, has been praised by groups around the world for their excellent work in, for the most part, in sustaining the salmon fisheries. Putting aside the political issues of false pass and etc., I'm not going to go there. It's just calm fish versus sport fish. Let's just leave that aside. But those folks there, Fish and Game, they pretty much know what the hell they're doing. So kudos to them. So anyway, Dr. Pinsky states, we were stunned to find that fisheries around the world have already responded to global warming. These aren't hypothetical changes sometime in the future. The researchers found that some species in some climate zones actually benefited from warming, and fish with faster life cycles sometimes responded well, sometimes responded badly to the temperature changes. Some responded by shifting their geographical range. I just did a video discussing that with you. But overall, said Christopher Free, once at Rutgers and now at the University of California, Santa Barbara, among the populations we studied, the climate losers outweighed the climate deniers. His colleague Olaf Jensen, also from Rutgers, said, fish populations can only tolerate so much warming. Many of the species that have benefited from warming so far are likely to start declining as temperatures continue to rise. Fishermen off the coast of Labrador and Newfoundland, fishermen in the Baltic and the Indian Ocean and the northeast U.S. shelf, have seen more productive hauls of fish, but the biggest losses were in the Sea of Japan, the North Sea, off the Iberian coast, and the Celtic Biscay Shelf. Many fish species are adapted to a precise range of temperatures. They flourish not just in specific marine ecosystems, but in thermal niches as well. Once things begin to change, they swim away or perish. Now, in the previous video, I described that as being stenothermal, being able to tolerate a narrow range of temperature, precise range of temperature, versus euthermal, which they can are organisms that can tolerate a wide range of temperatures. Many fish species, especially in the open ocean, tend to be stenothermal, and for that matter, stenohaline, tolerating a narrow salinity range. Now, an interesting, I want to go back to Labrador and Newfoundland for a bit, especially Newfoundland. Back in the mid-1990s, the Canadian government shut down the fisheries, totally shut it down, putting all those fishermen out of business. Why? Overfishing. As one of the fishermen stated at the meeting, said, let's face it, boys, we caught them all. Now you think about, you had the pollock, the cod, the hake, right? Big important food fish out there, and the overfishing, everything just totally collapsed, and they shut it down for a good 10, 15 years or so. It was a long time, and it just finally got restarted up there. So yes, they're saying that they're seeing more productive hauls of fish, but you're wondering how much of that is due to giving the fisheries, at least off Newfoundland, some time to recover. Anyway, I just wanted to mention that. Again, this goes back to a concept I'm always stressing about, increasing human population with finite resources, something's going to give. Just basic ecological principles 101. There is another little interesting thing that goes on. Fishermen in the North Atlantic have repeatedly observed changes in the available catch as the cod shift north and the sardines migrate from increasingly uncomfortable warm waters. Warming in Mediterranean waters creates conditions for organisms from the Red Sea and further south at huge cost to resident species. In other words, we have invading species from like the Red Sea and other areas further south moving into the Mediterranean because the Red Sea is getting too warm, so they're moving into the Mediterranean and they're displacing the species normally found there, the endemic species. So, what's the lesson? Fish stocks must be carefully conserved, ocean reserves protected. Researchers have consistently warned that global warming and climate change, especially when combined with changes in ocean water chemistry, because of the CO2, could soon start to constrain an important source of nutrition. An estimated 3.2 billion people rely on the sea for an estimated 20% of their animal protein, especially in East Asia, the Sea of Japan, one of the area's biggest losses. This means 15% to 35% less fish available for food and employment in a region with some of the fastest growing human populations in the world, said Dr. Free. Knowing exactly how fisheries will change under future warming is challenging, but we do know that failing to adapt to changing fisheries productivity will result in less food and less profits relative to today. It goes right back to the point I just mentioned a few moments ago. Increasing human population, finite resources. And the resources starting, even just from the principle of over-harvesting, we're putting such a strain, such a stress on the system, and then you throw in, changes to the ecosystem, we're screwing it all up. This is a recipe for very bad things to start happening. And they are. So, some things to think about. Warming seas are moving organisms around. They're shifting the geographical range, but it's also affecting what we can harvest. Something's going to give. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.